Hi everyone, right, we're going to look at some difficult substitution questions today. We're still going to be given the substitution though in these. The reason that it is difficult is because the substitution given to us is not in the form u equals like it normally is. In this question we can see it is use the substitution x equals u squared. Now first things first, you don't need to rearrange it in the form u equals. We can work with this, which we will in a moment. The fact it says with u greater than 0 is just there because it needs to be there. You don't need to focus too much on that. To evaluate, and here's the integral, we have limits which we'll need to change, and it's 1 over x minus 2 root x dx. Now, when we substitute things into our integral later on, there's one particular thing we need to pay attention to, and that is that we need to create something that is dx, because I'm changing this to be with respect to u instead. So I need to change something there. Now, usually what we do is we differentiate the substitution because it's in the form u equals, and we just rearrange it to get dx equals. Now, I'm actually going to do that, but by differentiating with respect, well, x with respect to u instead. I'm going to focus on the fact that it is x equals to start off with. Okay, and I'm going to just differentiate what they've given me, and that gives me 2u. Now remember, I want dx equals, so I just need to rearrange this. So it becomes 2x equals 2u du. Now this thing here can be substituted in place of this thing here in a moment. Okay, so that's a slightly different approach to what we would usually do, but it's all about creating something that can get substituted in. Now, in the previous examples we would have been doing, we would have ended up with something probably that still involves the letter x going on here, and we would just cancel out with something that was already there. However, this time it's all in terms of u, which is actually good news for this one. So I'm going to evaluate this. So it's the integral with limits of 25. Oh, no, it's not. Apologies, the integral limits I will need to change in a moment. I'll come to that separately over here somewhere. Okay, but this is what needs to change. Now, I need to get rid of the x's. Now, nothing's going to cancel out with this thing here, so I need to maybe think, how can I replace the x and the root x with something? Well, let's just put in the substitution that was given to us in the first place. We just need to work with this substitution. If we need to rearrange it, great. If we don't need to rearrange it, then that's absolutely fine as well, because x is equal to u squared, which means instead of x here, I can put u squared. Now I also have minus 2 root x. Now, if I was to square root the x, I'd also have to square root the other side. So I actually end up with just minus 2u there. Okay, so this here, by the looks of it, is looking good, but I just need to replace dx with something, and the thing I need to replace dx by is 2u du. So I'm timesing that on the end by 2u with du on the end as well. Now, I'm going to have to cancel something there in a moment, which will become quite obvious, but I also need to change my limits as well, remember, because these limits are in terms of x, but I need them now to be in terms of u. So if I'm dealing with x equals u squared, I just need to sub my values in for x. So I will have 25 equals u squared, and I will have 9 equals u squared, and I will end up with an answer of 5 and 3. Okay, so 5 and 3 are my new limits because I'm now dealing with u. Well, this can be simplified as well. With 5 and 3, I can put the 2u on top of the fraction and have u squared minus 2u on the bottom, and it's all now with respect to du. There is a common u on the top and the bottom. So this becomes the integral limits 5 and 3 of 2 over u minus 2. Okay, now there's a couple of ways of doing this, but when you integrate something that is usually 1 over, that becomes an ln term. So when I integrate this, let's not forget the fact that we'll have limits in a moment. When I integrate this, we'll have the limits of 5 and 3, which I'll sub in a moment. But 2 over u minus 2 is 2 ln of u minus 2. When I substitute the limits in, you will end up with, well, it's 5 going in there and 3 going in there, so it becomes 2 ln of 3, because 5 minus 2 is 3. Take away 2 ln of 1. Anything that is times ln of 1, well, ln of 1 is 0. So the answer is just 2 ln of 3. Now you can type that into a calculator and it'll give you that answer. But that is a particularly difficult question there, where the substitution was not u equals in the first place, but you just have to deal with what you're given. And that's exactly what I did. Okay, another particularly difficult question is this one here. Okay, in this question, we are given again a substitution. In case it's not clear, the substitution is this bit here, x equals e to the u. So we're dealing with ln's and x, which is not everyone's favourite thing in the world. All right, but let's just focus on what we are dealing with here. Now remember, we need to substitute something in for dx. Now let's just do what we did in the last one. It's not u equals, so let's just deal with what we're given. Let's find dx by du. Instead, let's differentiate this with respect to u. So it's just e to the u. Again, it stays exactly the same, but I want to get dx equals. So I end up with e to the u du if I take that up the other side. There's no limits to worry about on this one, so let's just go straight into the substitution. Now, that is 1 over, now remember x is e to the u, so that can go in there. This bit that it's multiplying by to the power of 3, I'm going to come back to that in a moment. I'm just going to put this dx on the end though, that was times e to the u du on the end. Now, ln of x, okay, this thing here, ln of x. Now remember that this is my substitution here, so if I'm putting x literally in there, then I suppose it would be ln of e to the u, which is maybe slightly more complicated to think of. Okay, now I can rearrange this x equals e to the u, the substitution I'm given in the first place. This has a different meaning. I rearrange it, I can rewrite it in a different way. This is in index form. And if I was writing this in log form, now that is log to base e, is always log to the base of whatever this is, of x, the answer, is equal to u. Or in other words, we don't say log to base e normally, we just replace that by ln. So that's ln of x is equal to u. These two things here, they mean exactly the same thing. Just one's in index form, one's in log form. So remember, I had ln of x here. I'm just actually going to replace that with u cubed. Okay, so we end up with this unusual looking thing here. Okay, now I need to simplify this. But remember, there's this e to the u on the top, which can cancel out with this e to the u on the bottom. And that becomes the integral of, well, it's 1 over u cubed, or u to the minus 3 du. Integrating that, raise the power by 1, divide by the new power of minus 2, that's minus a half, I guess, or minus that over 2, plus c, because there's no limits. Okay, very, very, very difficult questions, but hopefully you understood. I don't think there's anything like these necessarily in the sheet that you're doing, so the rest of today we'd like you to carry on with that. I know there's some of you who submitted, so if you want some extra work, then if you're really that desperate, then you can get in touch. Otherwise, all the best.